So today will be a semi-technical talk. My idea is to fluctuate between some storytelling about BPC and Elixir and some quick deep dive on some of the tech choices that we made over these years. 80% will be Elixir. All the rest hopefully will interest you. So 6 years, what have we done? My team was already running a system in production at the time. And it was a time of changes for the BBC. And we got some requirements that were complex, like personalization at scale. And with our numbers, the technology that we're using at the time were maybe not perfectly fit. So we start thinking, what should we do? And as every good team, there were disagreements. Should we move on to something else? Should we push on the technology that we were using? So debate, discussion, and we had a month and a half where different opinions in the team were producing different proof of concepts. Month and a half, at the end of it, Elixir was a clear winner for us. And so we had the language, and we had to convince our management. Now, our team was quite strong, and this was a winning point for us. So we were trust. But still, obviously, it was a complicated choice, a risky one. You know, everyone knows about horror stories about months, years spent in big refactorings. And also, our choices would have been impacting the ability of the whole BBC to serve content. So, we wanted to do it right. What we did? First thing, we replaced some microservices, a little bit out of the critical path. You know, still getting traffic on the order of thousands of requests per second, but you know, we could have less risks in exploring the language and the behavior of the language under pressure in production using these services. All good. It was a success, and it was the time to replace our main app. It didn't take very much, it was quick. And this was important because we couldn't lose too much time thinking and debating. So, very quick time to market. Now, this is a very, very simple mind map of what we are doing. I will not name the app for now, I will do in a few slides. So what we do? We have a proxy responsibility for sure. We do routing. I will talk a lot about routing today. We have our own custom caching solution. I will touch it a little bit, very important for us. We do enrich requests, you know, metadata, MVT, multivariance testing, these kind of things. We have our own rate limiter in the app. It's we call it traffic regulator. It's a little bit than a rate limiter. It's our own interpretation of how to degrade the user experience when too much traffic is incoming. We do a lot of resiliency. Resiliency tools are all over the application. They are automated, semi-automated, sometimes manual. They are used to avoid, handle, and react to potential incidents. As a whole, this is a hybrid. And it's a hybrid built around our needs, the needs of the BBC traffic flow. Now, let me go a little bit closer. Yes. Now, this is a little bit of a playful diagram, and I did it because I couldn't, you know, show all the details. But it's playful, but our responsibility is not playful because we are in a very central gateway position. If we go down, we bring down the entire traffic. And we take care of traffic going to very different services. Here you can see the shape is trying to express the complexity of different systems working on very different approaches. And we try to absorb and abstract all these changes. Still not naming it, but a little bit closer. Now, I will not go into the details here today. I don't have the time, but There are a few things here that could interest you. So, first of all, it's a monolith. Or at least it was a monolith at the beginning because we were not trusting our experience on the language. So we started with the simplest possible thing, and then we evolved it. At a certain point, we start extracting small chunks of the app and create a new custom application inside the cluster. It's built on top of plug for the request specification on the boundary, but then we have our own logic inside the app. It's not Phoenix, it's our custom purpose-built application. Now, I will not talk about the BBC. I'm trusting that you probably know about it. So I just decided to put some numbers just to put a little bit the ground of the problem that we need to deal with. So this is only web. There is also apps and data. Now, from my perspective, from my team perspective, from us looking at Grafana dashboard, even a minute of downtime here can produce a lot of problems. And it's the BBC responsibility to serve content, and my team responsibility to make sure this happens. Now, this is a digital-first corporation. It's a big company, really with a massive headcount of engineers, and it's a vibrant culture. At the moment, we are very busy rebuilding and inventing new things. It's big. Just to make an example, our Slack channel, our support, the channel that we use to support teams using our application, 450 people, yes. We have 40 teams, 45 teams. There are hundreds of committers in our repo. So quite a big environment, and for a big environment, you need a good name. Now, I was debating, who cares about how a team decided to call this product? Maybe it's not important. But a good name is very important for you to get your branding. And also, I think we got a very good name, so I think it makes sense to talk a little bit about this. So, this is Bruce Belfrage. He was a radio presenter during the Second World War. And one day he was reading the news, it was 9 p.m., and while he was reading the news, a air bomb hit the building. This is New Broadcasting House, where we work now. It was a blast. The noise of the explosion was heard by millions of people that were, listening to the radio. So, big explosion. Bruce Belfrage had like a couple of coughs, like, and then as calm as he could, continue reading the news. Now, I found this picture while I was looking for a good name. And his picture is in a very side entrance of the BBC. This was pre-pandemic. I was trying to find a lift that was a bit less busy. And there was nothing, there was just his picture. But I was curious, so I read a little bit his story. And from my perspective, it matches so well our mission as a team. Being able to read the news even when something bad happens. And in a way, it makes sense also for the language, if you see it, right? It's, you can have a little bit of a bad moment, something restarts, and you keep on as resilient as you can. So, Bruce Belfrage, and Belfrage is the name of our application. Now, a lot of resiliency, but the other big responsibility of our app, Belfrage, is routing. Belfrage is built around the idea of centralizing and standardizing the complexity of routing. Complexity because it can be very complicated to handle routes. And in order to explain why, let me go to the 1997. So December 1997, the BBC launched its website. Now, the same month, Christmas, they decided to broadcast for the first time the Queen Christmas message. And obviously, I don't know the numbers, I don't know how many people were using the website at the time, but I can imagine the stress of the engineers at the time with this kind of last-minute, quite high-profile service to air. Now, you can imagine, 1997, over the years, we accumulated a lot of content, a lot. which brings to a fact. You will not be surprised to hear me saying, over the years, technology get replaced, product get replaced. But the fact is that the content stays. And even more importantly, the links they bring to your content stay. There are millions of links around the world pointing to articles and content from the BBC. Now, I call it the geological stratification. And it's quite interesting because it's a problem. The longevity of website can create some tension on your routing layer. These are 3 eras. On the top, you can see a relatively modern article, very clear news article, and a very easy to validate identification. Mid-2010, okay, I know that it's news. I'm not sure if it's an article. Maybe I need some metadata to know if it's an article, an index page, or something else. And the lower one is something from the archives, 2001, I believe. Now, this one really, funny. It's quite hard to understand what is it. And these kind of problems are hard to manage in a performance system. Imagine this like fossilized imprints of an animal, right, on a rock formation. They keep their context, even today, even when the technology changes, they still bring a little bit of a closure to the time where they were created. Now, what brings this to us is that we today have 7,000 and plus routes, matchers, to manage at the BBC. Matchers that handle millions and millions of pages. There are redirects. Some come from the renderers, from our services, but still we need to maintain 13,000 redirects. And this obviously brings complexity. We need to maintain this historical context, as I was saying, but we need to do it in a performant way, and we need to do this in a way that change management is not a scary thing, right? Every time you deploy, you don't want to get yourself in a scenario of potentially discover one of your route is not behaving as you want. Now, first, Elixir thing here. My winning point. Metaprogramming can be complicated sometimes to manage. It's a delicate subject. But if you do it properly, if you really know your problem space, if your problem domain is clear, you can create very simple DSLs that can help users to understand your language. Now, we were experts on the domain, definitely experts, and we managed to build a very simple language, a root language, that engineers and non-engineers will understand. And this was so important because it allowed us to go very quick on the market, very quick on production without waiting for many engineers to understand the language. Remember the context, 99% of our users, our engineers, were definitely not Elixir engineers. They were using something else. And we could not wait for them to learn the language and agree on our choices in order to go live. Now, this is an example of a root file. We have a number of files that define roots. This is not real, it's just a small collection. But you can see here a very simple root. The first line, the handle news, a redirect, and a little bit more complicated one with parameters and some validation. There are many more, there are more complicated ones, but this is good enough for you to appreciate one thing. Handle news using news on page. A non-engineer will understand it. It's documentation in form of code. Now, this using news on page is a pointer. And it's a pointer to what we call root specs. These are configuration, your specification. Now, this is a very simple example, and it's just a subset of it. But for the sake of this conversation today, the first part for me has been very important. So we invested a lot on ownership. With such a big estate, it was important to understand which team, which runbook controls this content, what channel they use, because you can intervene in case of problem, and you know who to ask in case of problem. Now, the mid part, the pipelines, are business logic, which obviously was important for us because you cannot predict on day one all the needs, and definitely there are things like migration or additional configuration or additional metadata that you need in order to progress your request to handle your response. Not all the teams, all the specs use them, but have been very, very important for us. The last bit are examples. Now, in this case, it's simple. Like this is the news on page where only one path, /news. But there are much more complex specs which contain more examples that potentially indicate an ID or something so that you know at least one path that uses this spec. Now, examples are interesting because we can do things with them. Because of the compilation time, we can do things that allow us to test our configuration. So we compile, the example is used to validate that the root matcher points to the same spec. If it doesn't, the application doesn't compile. And this is so important because it gives us a strong guarantee that we're not producing a live incident. But even more importantly, we don't need to ask a lot of engineers to do unit tests and learn a language that they don't know. So in automated, we got this kind of tool, which has been very important to avoid, to get traction on the application. We also use the example for doing some sort of automated smoke test. Imagine this, at compilation time, we collect an artifact, which is a list of examples. We push via CI the application on a pre-live, on a near-live environment, and we do run a sort of smoke test. Now, because we invested a lot on ownership, we can inform the right team on their channel if something doesn't go well, so they can take a look. Another benefit of having your own language and your DSL is that at compilation time, you can do things. So you can build a efficient tree. You can traverse the tree for faster performance in routing. This is exactly what plug router does. But the good thing that if your need change or you have specific needs that cannot be covered by a library, you can change the engine without changing the contract. This has been very, very important for us. It didn't slow us because we had to deal with the politics of maintaining and updating documentation. But you can build different artifacts. In this case, we do produce an SQLite database from our root files and specs. We don't use this in any form in production for any root matching, but we use it for analysis, reports, or to power a small Phoenix app to understand better the state of the traffic, the routes of the BBC. Now, routing and routes are not just rules that you need to manage and define. You need to also operate on them in case of incident. It can happen that in the middle of the night, an operation team or an editorial team needs to point some traffic that is happily flowing towards a certain service to something else. And obviously, we don't want to do a deployment, be woken up in the morning and having to do a quick deployment. It would be risky. So recently, we introduced a tool. We call it Detour. And this is a way for pushing routes live without deployment. So the idea is we have a Gen server. It polls for changes on our source, let's say GitHub, our UI. And when changes are pulled, they get compiled, validated. And if everything is fine, they are just pushed in front of our normal root files. So this is an operational tool. It's very important because it can be the first strategic step towards an idea of decoupling routes from the application, which could bring it to a situation of self-service where teams are able to handle not only the routes, but when they can go live. I will change subject now. Confidence. Now, I will not be honest with you if I will not say that in the first year and a half, in such a big environment like the BBC, even with a team that was well known and trusted, we were the team in London building on this new fancy language. I will be non-honest with you. So we had to fight this, obviously. We had to control it because otherwise it could have been run out of control, right? could be a bit of a problem. But to be honest, there were some wobbles, some questions inside the team. Why are we going away from our very well-known language or technology to go to something new? And to be honest, there were some concern on myself as well. First year, everything seems very good. Performance is perfect. But what will happen in 6 months, in a year time, when feature on top of feature will potentially slow down the entire thing? So one day on a train, we were going back from Manchester. We probably heard the thing, trendy in London, probably. But we were talking, and we decided to take this process, this practice. We call it LTDD, load test driven development. And it's a little bit of a funny game around TDD. But the idea was to build practices and tools to load test everything we were building with the minimal attrition we could imagine. So everything should be load tested. And this is a practice that we still use today. So I cannot imagine a sprint when we don't discuss a load test result or something around load. So we build a number of tools. One is a very small, it's Origin Simulator. It's open source if you want to have a look, very simple. It's a very simple plug with a couple of gen servers. They get a recipe that simulates the behavior or misbehavior of an origin of a service so that we know that at a certain point they will start returning a certain error or a slow response. The idea is that we can simulate an happy scenario, not only to test the performance of your application, but also to test the what if. What happens if we get an unexpected status code or we time out or things like that. And because load tests don't tell you always the truth, we also added Go Replay. I don't know if you know Go Replay. It's an open source Go app. It simulates live traffic, just to simulate the quirks of what happened on a live environment. We automated it. So the idea is that 9 to 5 working hour, we read the logs from the previous day and we push it on a test environment, still supported by the Origin simulator. And in this way, we keep our test environment under certain pressure and with flow traffic that can simulate what could go live. Another thing, very quick, is this. Okay, observability, your metrics are very important to keep track of your performance. One small tool that we found very useful is to record our internal latency. So this is our internal, between the boundaries. And we did this in recording only the request part and the response part without any I/O, without any waiting for our proxy response. And by segmenting it, we can A, understand where there is pressure, when there is slowness. B, potentially we can understand if an update, a change that you have done as introducing even a sub-millisecond improvement or not. So we cannot end up in accumulating latency without noticing month after month. This has been very useful for us. Now, traffic is not exactly a line floating around on a Slack thing. Sometimes spikes. And for us, when it spikes, it can be complicated. At the BBC, a spike can be an election night, can be a prime minister resigning after a few weeks, can be a football match, a lot. And obviously we need to take care of them. We cannot fail in that moment. It would be complicated. It could generate fears. Now, these are two spikes. On the left-hand side is a football match. I will not show the y-axis, so no numbers, I cannot share them, but you see, quite big and spiky. There are two football matches overlapping, just to make things a little bit more interesting. On the right-hand side is a mobile app for news. It was a breaking news. Now, on the left, there is a lot of personalized traffic. It's the dark green line there. And on the right-hand side, our problem is notification from apps. You get notification, everyone jumps on your app or your website exactly at the same moment, which obviously can generate problems on your system. Now, Elixir is perfect for these scenarios. And the reason is predictable. It's by design, it's built around the idea of concurrency and message passing, the fault tolerance that comes from the supervision. All these things make the language very, very, very predictable. Please read it, because I will not talk about this slide at all. And the reason is, because you are here for this reason probably. You know this, right? You know this very well. And this is probably one of the reasons why we are here all together. But we wanted to be sure that our engineers at the BBC will understand this, because they didn't know. So what we did was going in tour in our offices in the different parts of the country and doing very technical presentations. These are from 2019. Okay, quite graphical, but definitely we went in the details here. And the reason was that we wanted to point off our engineers' curiosity, to let them get hooked by the idea of the language. Because that was meaning getting trusted, getting, supported, and potentially getting people that would be interested in joining us in our work. So definitely this was very important. I could talk for an hour about this, but I will not. Now, our previous app was running on around 100 servers, just to put some numbers. And we didn't have any personalization, so the spikes that we were experiencing were definitely lower than what we get now. Right now, we run on 12 servers. So obviously, there is definitely an improvement. The language is more efficient, and we know this. But why we were running on 12 servers before, or 100 servers before, was to give the application a bit of headroom, a bit of buffer. If a big spike arises, a single node misbehaving could have an effect of collapsing the entire system. And the fear of things going down meant that we were overscaling. Now, Elixir changed the pre-scaling equation in my perspective. And the reason is that the robustness of the application, the fact that when there is pressure, instead of a crash, you get a slowness that you can control, mean that you can afford a more efficient usage of your servers. Then, yeah, we can scale up, but in our case, sometimes we cannot scale up in time, but we know that if the big bang arrives, the big wave arrives, yeah, maybe we can be a little bit slower, but we don't crash, we don't go down. This is important because, yeah, you can save money, less server, but the peace of mind, the fact that you can be focused on building things instead of worrying about firefighting an incident is very, very important. It's important for the business. Now, this connects all the dots. Look at this: spikes, confidence, and the language. The impact of the predictability of your tools on a small team like ours can be a really, really a game changer. You have this kind of situation where you trust your tools. I can see my team visualizing the flow of traffic, the communication within the dynamic part of the application in a way that is incredibly good. So we really can visualize the flow of traffic inside the app. And this is proved by data. We got much less incidents, definitely much less. And when incident happened, the time to debug, the time to understand what's going on, it was so shorter. So you see, trust fewer incidents, a team that feels more confident, or even applying changes on a system. Very professional slide here. The idea is that, yeah, we have fire coming potentially from a big spike, but sometimes fire can come from your services. We are very busy, everyone is very busy, multiple teams working at the same time in delivering important features. A bad day can happen. When a team does a mistake, we could get spikes of error coming from our sources. Now, when we built Belfrage, our app, the beginning, when we started doing our proof of concept, on day one, we really wanted to build around the idea of unhappy scenarios. It's very sad if you think, even the name that we took is about an explosion. So definitely we were thinking about, what happens if something goes wrong. And one thing we did on day one was this. We assign a sibling to our root spec. So to our configuration, we assign a sibling. And the sibling is a friend that has a much more runtime concern, which is monitoring the health of the system, or better, of the traffic assigned or owned by the root spec. So it's a one-to-one. We have like hundreds of these root states. There is a gen server, and there is a dynamic supervisor, if you're wondering. And the state of the gen server keep count in cycles of, number of 500s, timeouts, timings, things like that. So these things together give us a sense of the health of the traffic connected with this spec. Now, on the left-hand side, you can see a request. It's going through a certain pipeline. At a certain point, we do a call to the root state to understand the current health. We get back a very simple message, say throughput 100%, go on. So we continue our preparation of the request. The request finally gets sent to our service, our origin. And unfortunately, in this case, the origin returns a 500. So what happened? There is a tiny cast message. We increment the number of 500s, and we send back the request to the user. Now, more requests come. Unfortunately, the number of 500 increases to the point that we reach a certain threshold. And at this point, our root state became a circuit breaker. Now, I will not talk too much about how circuit breaker work. It's a cycle of states, red, amber, and green. And the idea is that we are going to protect the origin that is struggling, bad deployment or something, from being overwhelmed of pressure coming from traffic. So we stop the flow, and we do an early return, and we return back the request to our user. Now, because we don't want to send an error to our users, because obviously it's not nice to send a 500, we do replace the 500 error with the last known well-working version of the page. Stale on error, probably you know this kind of concept, but the idea is that we done our own tiny solution. Yeah, I think I have a bit of time to talk about this. So the idea is that we have our own ETS cache table, very local because obviously performance is important, but then we have a distributed cache that we can use in case of cold caches or prolonged incidents. So we get back the 500, we replace it with the version of the page that potentially was expired, was a little bit too old, but it's still better than sending an error to our user. Now, in action. So another spike. This time, unfortunately, there was a blip that lasted probably a couple of minutes. But the numbers were quite big. Obviously, still, I'm not showing the numbers and the axis, but it was a quite big error. So what happened here, there was an error coming from our origin for reasons. Root state, our gen server connected with this traffic noticed the problem. If you notice, there is personalization it's still the dark green line, the lower one. The root state noticed the problem. We reach the circuit breaker, it flips, and at that point, we start serving all errors instead of calling the origin. And because our errors, we do replace them with what we call fallbacks. So a last well-working version of the page, and in this case, there were probably thousands and thousands of errors. Not a single error has been sent to our public. Okay, another change of subject, but this one is to talk about the final and I think very subtle benefit of the language. To do this, I will talk about my team. 7 people, 7 engineers, very busy building things, very busy building new features, but also monitoring the health of the system, the performance. And they deliver. But it's even more than this. We are sometimes a support team, so unfortunately we have to look at incidents and sometimes do reactive work. And we do deliver. And okay, it's a brilliant crew of 7 fantastic engineers, But our secret sauce is also a language that can be very, very dynamic, very, very flexible, very easy to understand and manage, so that we can build incredibly interesting software, very performant, while being busy on our own day of support. So this has been a winning point for us. It's been good for the BBC as well. Now, I bet that everything I say today was not a full surprise for you. You were mapping my talk with Gen Server, Supervisor, Gen Stages. And these building blocks made a perfect language for a big organization. Because we are relying on predictable patterns that you can see in the code and can make the code understandable. Your next hire will have a much shorter time to get productive than in other languages, because we tend to use the same approaches all over the code base. And the language doesn't change every time you go on holiday. Think about it. This is so important, right? Which means that you can rely on a very stable ecosystem. The documentation is spot on. I don't know how you think about it, but we, as I said before, we sometimes get people from other teams joining us out of curiosity or because they want to work with us for introducing a new feature. And they are not expert on the language at all. What we do, the first thing I do is sending them to the Elixir guides, because they are so good. And I know that then in a couple of days they will understand the language, understand the reason behind the language, and they will get hooked. So very good, important feature. Now, we're going to talk a little bit more in the future about the story around how we introduce Elixir at the BBC. My colleague, Guy, who worked with me in my team, is writing an article to talk about how we convince the management and how we managed to go live with Elixir at the BBC. It will, hopefully soon, will be published. And if there is interest, we can go through some technical choices on what we've done at the BBC via blog post, hopefully, or if you want, with another talk. But I should close my talk with, wise word, a recap, some thoughts. And I was doing this, then something happened, and I think at cost of destroying my performance today, I will do something a little bit different. So, bear with me. I will use someone else's slide to close my talk. So, these are slides from 1999. Just to put it in context, this is 1.5 years after that we, as BBC, launched the website. So very, very interesting old material that I found by chance because I was trying to find a picture of a telephone which was part of the presentation. It's massive, they're very big. And I found this PDF, and I was scanning the pages, quite pleased to see words that I was recognizing from such old document like, supervisors, ETS, OTP. And then I reached the last pages, and I was surprised because the conclusion were so close to the one that I had in my presentation. Very, very close. So I understand this is a different era, different team, different language. But we were reaching the same conclusion. So now, just to finish, I will go through 3 slides, and I've highlighted some points that for me were very fitting. So, number 1, experiences with Erlang, which for us will be Elixir. Shorter time to market, yes, important. Easier to meet future demands, absolutely, tick. High productivity, yes. Easy to learn, absolutely. I was just talking about this a minute ago. High programmer satisfaction, yes. Why was AXD 301 Belfrage successful? High pragmatic, incremental, yes. Good technology fit, definitely. And the last one, which contains a tiny bit of sense of humor that I really like, is this. How did Erlang make it to a commercial product? Working within your organization, very important, and relatively success in convincing management. Thank you.